On the print, generally speaking, there are going to be details that are brought out into breakouts on the print, and they're highlighted. So you'll see that we have detail D, detail B, detail F. So we're going to take a look at one of these details, and we're going to pick detail F. And we're going to highlight that a little bit, looking at these various callouts. And you're going to see that they're on here, that there are 3 radiuses that are called out. But if we look at this print more closely, I'll just zoom in on that, you'll see that really there are 4 radiuses, because there's an over radius here on the smallest radius. So as we go through each one of these details, we would be able to go into the solid model to measure features if, in this case, dimensions are missing. So we jump over to the solid model, rotate this around, and go into any of these corners, but it looks like we've got this corner here, and that's really the over radius area. So we would be able to go into here and we'd be able to measure that radius. Other details where we only have a 2D view of this channel, for example, here and here on this detail F, where again, we're only getting a 2D representation of that there is a channel in here. You can see that in this area here. And having the solid model is pretty critical for our ability to get a visual representation of what that channel looks like and what that tool would have to do. So looking at this part, imagine that we have a tool coming down into this cavity. It's going to have to go in here and create this radius and create this channel, but we have this channel right next to this wall. So that's a challenge for us in order to get a tool that's that long, going to reach down in there and be able to still mill that channel. So when we go through all of these parts and all through these details, we have to consider, again, the best way to fabricate the part in the most efficient way to do it. However, having the solid model is critical for us really to be able to determine some of these radiuses, the depth of the channel, and looking at the solid model versus the PDF, it's a huge advantage. Another point to make regarding the solid model, on the solid model, you'll see, let me back up to this PDF and we'll look at some of the notes that are being called out. So as an example, from a fabrication standpoint, we've got 2 sets of notes here for helicoils. So we pick those up and we go and look at those areas on this part. And we say, okay, we've got all of these holes that are going to need helicoils installed. So we're going to go zoom in on that part, on that feature. And what we see on that feature is that we just see a drill hole, and we see a drill point at the bottom of that hole. So when we go into that feature and we see that, there's no feature for it. We can't dimension from that thread, so cam work would be required. And being that it's not a flat bottom, question we would have is whether or not that is required, or whether or not we can modify that and make it a flat bottom. For the DFM, we would want to consider milling the hole instead of drilling the hole, and then thread mill the threads rather than use a tap. And that would be something to consider to create efficiency at the production quantity. I mean, all these details are very important for the DFM. But so staying on the helicoil for a minute, because we've got 6 in this location and we've got 12 running around the part. So at a quantity of 100 relative to our total fabrication, and we do the math, we've got 1,800 holes. So from 2 perspectives, one is the machining of this hole, and the faster we can machine the hole and the more efficient we can do that, clearly we're going to save time. We're going to save money on that. Also, it's not just the machining of that, but also the installation then following of those 1,600, 1,800 helicoils. Because that's a tooling cost relative to equipment and time, labor, and any other costs associated with getting those on tape and reel. Because again, you don't want to get into some manual process of installing 1,800 helicoils. So one small detail on the part relative to the size of a hole or the depth of a hole or the thread of a hole leads you down this path of trying to determine how best to approach that. And this will be the give and take, right? As we go back and say, is it possible to change the feature of the hole? Is it possible to go to again, a flat bottom hole? Is it possible to go to a milled thread instead of a tapped thread? Are there objections to that? Is there a reason for the manufacturing specification that can or can't be changed? So these are all the things that we're going to be looking for as we go through the process. The last thing we look for, other than obviously all of the features, is we start looking at our finishes. Any call out for surface finish of the material itself, or any sort of plating or coating that would be required in order to have a turnkey finished part. And in this case, we have no finish call outs on the material itself, but we do have call outs for a conversion coat, which is really a chromate. So we have a chem film chromate that goes on all surfaces. And then as a selective or secondary process, there would be an anodize that would go over the top of that chem film. So looking at this print, you're going to see that there are hatched areas, and they're asking to mask all of these hatched areas to maintain the chromate, and all of the rest of the areas that are dark are going to be anodized. So that in and of itself is another level at which we would then consider, because of the masking that has to be occurring prior to plating, it is going to ask or drive questions regarding deburr and surface finish of the material. So number one, it's going to impact the machine surface finish. So we're going to have to determine more of the speeds and feeds of the tools. And we're going to want to consider media blasting or tumbling for all of the surfaces to not only deburr, but also to create a uniform finish across, so that when the anodize and the chromate goes on, that there are aesthetically pleasing as well as surface finish prep for accepting these finishes at a higher level to allow them to be more efficient and more robust throughout their life. So as we've gone through, and these are just some examples of how the DFM process evolves, right? So we can go through this, and we could go through every detail on this print, but what we wanted to do today was just give you a basic understanding of all these points and how they're critical to understand from a DFM perspective, that we know every feature and how best to approach the fabrication. Obviously, the goal is to get a better understanding of how the part can be manufactured and end up with the most efficient way to do it, reducing cost overall. What you will end up with is a red line drawing of the areas that we have considered. So as we went through this PDF, and we'll go back and we'll say, on here, we're highlighting a radius. These will all be redlined where we're missing either dimensions or call outs altogether. And we will redline all of the PDF. So you get a red line drawing of all the areas we considered and all the areas we discussed, a list of the specific challenges that the part presents, and then suggestions for improvements. So whether you are starting a new engineering project or simply looking to reduce costs of an existing product, please send us your files for an in-depth DFM analysis.